Well, thank you, Mr. Chairman, and I'm very pleased to be here because I think what you and Senator Martinez are doing is very important for states like yours and states like mine that are hurricane prone. And I also have maybe a more far-reaching and not yet proven suggestion in a bill that came out of Commerce Committee a month or so ago to look at not only ways that we are able to better predict the impact and the course of the hurricanes, which you all are doing, but also are there ways we might consider through research mitigating the effects of those hurricanes with some kind of intervention. So I hope that my bill passes. I hope that your bill passes, and I want to put my statement in the record, my opening statement in the record.
Without objection.
But let me just, I've tried to ask my staff here what has already been covered, so I'm going to try not to duplicate, but I do want to ask Dr. Wells, because I had the personal information while we were all just watching Ike by the minute. I was amazed at the accuracy of where it would hit, when it would hit, intensity that your Ranger computer was able to model, and sharing with all of the federal agencies, the Weather Service, the local and state emergency services. It was the best I have ever seen. And so I want to ask you, what did you learn from what you were able to get? Is there something more that can be done that we should explore, or is there something new that you think should be added for this year's hurricane season? Because the ability to track the way you did, and what was amazing is to look at it after the fact, that everything you predicted was exactly where and when you had predicted it would happen. So now my question is, we're going into hurricane season, and what more should we be doing, can we be doing, and what is this new Ranger capability going to do for the rest of our states that are so vulnerable?
Well, I think, and Dr. Spinrad has also talked about their success at NOAA in running a forecast model on Ranger. We were running the hydrodynamic storm surge forecast. They were running the actual track and intensity forecast with a different model. We were sharing the computing resources there. There's 60,000 processors to share. The New York Times had a nice graphic that showed Ranger in relationship to all the other supercomputers a couple of months ago, and it was the 6th largest, and all of the other supercomputers shown in the graphic were at national laboratories or similar federal large facilities. This is a university resource that's shareable through the NSF with many other investigators researching a very wide variety of problems. It's a highly adaptive computing resource that we can use for our hydraulic and hydrodynamic models, as well as the hurricane forecasters can use.
And I know you were sharing with NOAA. Is there anything more that would be able to, between NOAA and the technology that you have, that would get any better or more helpful information to the people on the ground who are trying to prepare?
Exactly. I was about to say, probably the area that we haven't explored to the degree that we need to are some of the ways that we can visualize the information from the models, the outcome of the model, and put it into a context where individuals, where the public can really assess their personal risk. I think there are lots of model outputs that we see. There are maps, there are various other ways of displaying these results, but they just don't always capture the imagination of the public in general, and they cannot see themselves in their homes as being vulnerable to this particular event that we're attempting to give them the model results. We understand that, and we can actually place first responders in the field. And I can provide information to Mayor Thomas and Galveston saying, here's what your community is going to look like tomorrow. But I'm afraid that we are not doing as effective a job of changing the attitudes and the personal comprehension of risk that citizens have. And I think that modeling visualization, and this can be cinematic, three-dimensional, really dramatic ways of presenting that kind of information both on storm surge and wind damage and inland flooding, where people see their neighborhoods and even their residences as affected by the event. That's the future of this. We can get to that level of demonstrating what the impact is going to be. You always hear these people after the event saying, oh, I knew that this was going to be a very bad hurricane. It's going to be as bad as Camille or as bad as Carla, and I lived through that, and I realized, but I just didn't think in my part of town or in my neighborhood or at my house it was going to be as bad as it was.
Well, one of the things about Hurricane Ike was the flooding, the heavy, not just heavy flooding. I'm thinking of, it's not a tsunami, but it is that forceful flooding. I flew over the area on the other side of Galveston, where Bolivar Peninsula, not island, but the Bolivar Peninsula. I've been there many times, and I was flying over it, and I was thinking, gosh, this must be a new construction area because there's nothing here. It was a new construction area.
That material was 10 miles away in Chambers County.
And that's why all you saw were sticks in the ground, and there were no turned over refrigerators, there was no debris, there were nothing. So I thought, well, it's new construction, and I realized, no, I'm in the heart of Bolivar Peninsula where all the houses are. And yet there was no debris. It had gone 10 miles up, and that's what people aren't prepared for. I mean, I grew up in Galveston County, so I lived through Carla and Camille, and so I've never seen anything like it in my life. And so that's what you're talking about. People can't visualize that they're going to come back and see sticks in the ground and not a broken air conditioner, not a broken sink, nothing.
Right.
It was unbelievable. So is that what you mean when you're saying people aren't prepared for what is actually going to happen in their immediate neighborhoods?
They just have the general concept that this is going to be a bad event, but they cannot personalize it and see it in terms of their own geography, where they live. And I think that we have now, and we certainly will have better in the future, a means of doing the modeling that predicts that impact and the means of delivering that information more effectively. We probably need to study how people respond to different kinds of information that's given to them. I don't think that there's enough research to show how people conceptualize their personal risk in this kind of event. It's probably the same for earthquakes and other natural disasters. I think we really need to take a careful look at that, because we could have the greatest science and have the best knowledge of the physical dimensions of the impending event, but if we can't communicate it, it's not going to make a difference.
Let me just ask one other line of questioning to anyone who would wish to respond. In the bill that I'm putting forward, it's trying to study the present and the past to see if there is any future in weather modification. In other words, just as an example, I don't know if this is possible, but I think we ought to be looking at it. If you see a certain type of hurricane 100 miles out in the Atlantic, and is there something that could be done there that wouldn't stop it but might make it less powerful when it comes into Florida or into Mississippi or Louisiana or Texas or Alabama? Is there something that we haven't looked at from the past that would give us an indication of maybe a mitigation of the impact, because the damages are so much higher now than they have ever been because of the intensity? So my question is to anyone. Yes.
Senator Hutchison, it's a very important question you ask, and one that, as your bill states, got a lot of looking at in the 70s, but there was then a drought, so to speak, of weather mitigation activities. like to make 4 points with regard to modification. I think number one is you really need good numerical forecast models to do weather modification, especially of hurricanes, because you need to know that the modification you're going to try to impute to the hurricane will have the intended effect. And so that's a challenge in and of itself, and it really requires the best research and the best forecast technology you could possibly have. And you know, we have run simulations of tornadic thunderstorms, of hurricanes, and we know through our simulations anyway that in fact there's no question you can change the course of a hurricane, you can kill it off, you can kill off a thunderstorm before it produces a tornado. But that brings me to the second point, is how do you actually then implement that change? And that's really an engineering problem. And there have been some far-ranging, you might say, approaches proposed, all the way from launching ballistic missiles into thunderstorms to doing all kinds of things in space for hurricanes. That is the real challenge of how do you actually deliver the disruptive influence that will change the course. We know in our simulation models, we don't say how we're doing it, we just cool the ocean surface temperature, and sure enough, the hurricane dies. But then the question is, how do you actually do that? So the first point really is you have to have good forecast models to know that the change you're trying to achieve, and in fact is the one that's going to occur. You're going to get what you asked for. Second thing is really the issue of how do you deliver the influence. The third one is an interesting one, and that is the unintended consequence. For example, hurricanes, although they are destructive, they have some very positive aspects as well in terms of bringing fresh water inland. There is a lot of flooding, but they are an important source of water recharge in the hydrology system. Another thing about hurricanes that's very interesting, we don't know why they exist. We know why weather occurs. It's the atmosphere's way of trying to reduce imbalances of temperature between the cold poles and the warm equator, and it never is successful at doing that because the sun keeps shining all the time. Hurricanes, we don't know why they're there. We don't know what purpose they play. And so that has interesting implications in the climate system. If you got rid of all hurricanes, for example, what impacts might that have on the climate? And this is where numerical models come into play. And when we actually are able to resolve hurricanes with climate models, which we can do now, we can run 100-year climate simulations. And when a hurricane starts to form, we can kill it off and then compare that simulation with the case where the hurricane is actually allowed to continue. So the third point is really one of unintended consequences. The fourth one is really relates to ethics and legal issues. And I know you run into this in Texas, we do in Oklahoma and in Kansas, where you're doing rainfall enhancement studies or hail suppression. You're spending a lot of money actually doing that, in the private sector. And somebody in Texas says, well, you've bled all of the water out of my clouds in Oklahoma Panhandle, and the farmers in southwest Kansas get very upset. So it brings in a lot of interesting legal challenges as you cross state lines and geopolitical barriers and things like that. But I do think, and I read your bill, and I think it really is time for the nation to get serious again about weather modification. And as your bill pointed out, and as the National Research Council study showed, there really is no compelling evidence that this works. But we have much more powerful observing systems now, which we need, mobile radars, ground-based radars, things like that, aircraft, and especially numerical models. So I think the scientific community is really well poised to address the important challenge you bring across in your bill. So I applaud you for introducing it. There are some interesting non-scientific and ethical and legal issues as well. But the other point I would make just in closing here is that, in fact, when you study modification of the weather, the kinds of questions you ask have great relevance to some of the other issues that we deal with in terms of predictability of the atmosphere in general, and how you do data simulation, as Dr. Spinrad mentioned. So we might think of it as modifying hurricanes or doing advertent weather modification, but there's a lot we can learn scientifically in other areas and challenges in weather forecasting when we're studying weather modification. So it has a double-barreled positive effect, I would say, on studying the issue of weather modification, but all the other things that it relates to, we can get a great benefit as well from that.
And I want to go to Dr. Spanrad, but that is the purpose of the bill. It's not only to see what might have an effect, but what are the unintended consequences. And I think even today, when you have cloud seeding in one area, we need to know if it affects weather in another area adversely. And I think that's something that, because we did take a pass on getting data really many years ago, we really need to know now more where to go and what the consequences are. Dr. Spinrad.
Thank you, Senator. I'd just like to add 2 points of emphasis to Dr. Drogemeyer's comments. And the first is, before we modify any system, we really have to know what the system is comprised of. And if we look, for example, to hurricanes, it's only in the last several years that we have begun to understand the role of phenomena such as El Nino, La Nina on hurricane development. And something that's emerging right now is we're discovering that dry air masses coming off the Sahara have a very strong influence on whether hurricanes will form or not. 5 years ago, we had no idea of that. And so I'd say the research that goes into understanding the system and the development of any weather phenomena would have to be addressed, whether it's to improve the forecast or to engage in any kind of modification. My second point is an emphasis on the unintended consequences, and I'd hope we would include in that some understanding of the consequences to the ecosystem itself. There's some indications, for example, that because hurricanes have a major stirring effect, they reintroduce nutrients into the environment in the Gulf, for example, there are potentially beneficial consequences of hurricanes to the productivity of that environment. So it's the physical consequences, it's the societal consequences, but it's also the ecosystem consequences as well. Thank you.
Yeah, I think all those points are absolutely well taken and would be part of any kind of study. Basically, what I want to do is start getting the data, and then from that know if we do modify or don't modify. That's when you start getting into the consequences, but it just seems like not knowing is not very enlightened, so hopefully we can do something about it. Thank you, Mr. Chairman. Appreciate the opportunity.
Senator Hutchison. Earlier, Dr. Spinrad, you were talking about the importance of measuring the winds at the surface of the ocean as a means of trying to predict the direction and intensity of hurricanes. And we used to have a satellite that measured that, but that satellite is either on the blink or it's about to go out beyond its designed life. And there was an attempt to get another one in there called a scatterometer, and the short name was QuickScat. Since we don't have that capability, how do you fill the gap, and what are NOAA's plans for the next generation of a QuickScat?
Surface winds are important. I think there has been some debate as to the full value of those data in terms of improvement of the forecast. Nevertheless, I think most of our scientists and forecasters would say having those surface winds is of value. QuickScat, in fact, is viable, is fueled to run through 2011 if all things go well. We are in discussion with NASA about development of a next-generation ocean surface vector wind sensor, which would fulfill the same data requirements as QuickScat does. We also have ongoing discussions for data availability from a scatterometer being developed by the European Meteorological Satellite System, and that would be called ASCAT. Finally, I would add that, as I mentioned earlier, there are some additional approaches that we are testing, one of which is the use of unmanned aerial systems, which we can actually fly into the hurricane and directly acquire the surface winds, near-surface winds. And then the other is a new piece of equipment that we have installed on aircraft and the Air Force aircraft, and that's called the Step Frequency Microwave Radiometer, which allows us to view the ocean's surface and extrapolate from that what the winds are. So there are a variety of different approaches that are at hand. We believe with the viability of QuickScat currently, we have time to develop the solutions so that we can, in fact, get those surface winds.